So now we move to example 5, which from the notes, the example 5 is the theorem, the last theorem, which we have Arnold as trigonometry. Okay, we look back. So from this equation, I just kembangkan and I will get d square y plus a square y equals to cos bx, which is a trigonometry. Okay, then for the auxiliary equation, we look inside this one, so we get m square plus a square equals to 0, and we need to find the m. So for m, after I use the formula, I will get complex root, and for yc, I will get this one because it is complex root. So from the Euler's formula, I change into this one, cos ex plus I sin ax, and for negative is minus I sin ax. Then I substitute it back into the equation yc. So for yc, I get c1 cos ax plus I sin ax plus c2 cos ax minus I sin ax. So I just put it with their partner, c1, c2, and negative c2. So after that, we can factorize it, and it will looks like this: c1 plus c2. No, I'm sorry, for the partner, we can partner it with the same trigonometry, which is 3c1 and c2 cos ax. So we can factorize, and we get c1 plus c2, which is considered as c1, and c1 minus c2 I sin ax we consider as c2 sin ax. So we get yc is c1 cos ax plus c2 sin ax. So for this theorem, it have particular solution, which is because a is constant, so we consider for two cases, which a not equal to b, and for second is a is equals to b. So for the first case, for this case, a is not equals to b. So because a is not equals to b, so we change the equation to d square plus a square yp is equals to cos bx. Okay, so for yp we will get a cos bx. Then we just substitute a cos yp into the equation, then we get d square plus a square yp. We change to this one, so I get a cos bx is equal to cos bx. Then after we solve it, and I will get a square minus b square a cos bx is equals to cos bx. Then because now we want to find the value of a, so we can put the a to the left side, and after we cancel out the cos bx and cos bx, I will get 1 over a square minus b square. So we have find the a. The a is 1 over a square minus b square, right? So for the yp, we can just substitute. We look back this one, so a, we change it to 1 over a square minus b square, and the final is yp is equals to cos bx over a square minus b square. Okay, now we move to the second case, which is a is equals to b. So for a is equals to b, as it is the same because a is equals to b, so this square plus a square, and yp is equals to cos ax. So by using the method of undetermined coefficient, because the root is complex root, so for this one, I explained in the class, it has m prime. I'm sorry, it is on m equals to complex root. So yp is equals to a cos ax plus b sin ax. We look back to the undetermined coefficient to get this equation. Then for modified yp by multiply with x. Actually, I still don't get it, but as you say, we for this one it is a product. Okay, like madam, like doctor said in the class, it will become a product. Okay, so we differentiate it 2 times, just as this one, the first case. So for second case, we also differentiate 2 times. Okay, after we differentiate 2 times, we will get this one, b square plus a square yp equals to cos ax. And yeah, because we have get this square yp, so we can substitute it into the equation, and we solve all of it, and after we plus minus and cancel out everything, we need to find the value of a and the value of b. So we compare, okay, because sine, there have no partner. We compare with the original equation. So sine doesn't have the partner, but the cos have the partner, so we will get the value of a and b. Since b, we have the value at the right side. The right side is cos as only, so it's equals to 1, and b, I will get 1 over 2a. So we substitute into the equation, and we get yp, since a is nothing, 0, so it's 0, consider as cancel there, so yp is just only x over 2a sine ax. So for the general equation, we combine yc plus yp. So make sure for the both case we combine. This is for first case, I will get the only difference at the yp. For this case, also at the yp. That's all from me. Thank you.